Math 2, Unit 4.5. Today we're talking about indirect proofs. One nice thing about indirect proofs is that we are only learning the first step of the proof, and that is all you have to do. Okay? I know. What does anybody know what the word indirect means? Like, could you give me an example of indirect? Okay, not intended to something, but it ends up going to it. Okay, good. So basically, the main idea with an indirect proof is that if they say something is true, you basically do the false statement of that, the opposite. Okay, and then you prove that to not be true. Kind of weird, I know, but can you think of an example like in your life, like even let's say like with your parents or your guardians, like they maybe say, you know, you can't do this, and you try to prove them wrong by being like, well, what about this? Or what about that? Do you guys know what I'm saying or no? You guys always agree with your parents? So like when they say something is unsafe and they don't want you to do it for whatever reason, do you guys ever try to prove them wrong? Yeah, and do you usually give counter examples? Okay, that's like an indirect proof. Okay, so all we're learning about today is this step 1, which is on page 232. Okay? And that is that you state as a temporary assumption the opposite. Okay, so moving on. We're going to just actually move into trying to make counterexamples. So page 232, or sorry, 233. Okay, so it says, suppose you want to write an indirect proof of each statement as the first step of the proof. What would you assume? So, if your triangle BOX is not acute, what would be a counterexample? Like, what would you say? What would you assume? Albert. Assume BOX what? Very good. That's exactly it. Except for, just so you know, when we're doing these proofs, you're going to put assume temporarily. That triangle BOX is acute. And that's it. That's all we're doing today. And guess what? There's test questions like this, which is also hopefully nice. Hopefully you'll get them correct. All right. B, at least one pair of shoes you bought costs more than $35. So you're still going to use the number 25. How would we use it but still using the same number? Good. Assume temporarily no pair of shoes costs more than $25. All right, still on page 233. At least one angle is obtuse. Exactly. Assume temporarily. What would I write next? Very good. No angle is obtuse. On number 2, where it says measure angle 2 is greater than 90, what is the opposite of greater than? Less than, but it's actually going to be less than. Actually, that works. Okay, so measure angle 2 is less than 90 degrees. And I forgot to put assume temporarily. Why are we just putting it? Why do we need to put assume temporarily? Because that's not exactly what's going to end up happening, right? So it's only temporarily that we're going to assume this so that we can prove it to not be true, which means that the other has to be true. Okay? All right, turn to page 234. Okay. So I'm going to let you go ahead and figure this out. You can actually show me on your fingers which two you think are good. Which do you think are true? Good. 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 No. Yes. Yes. No. Yes. 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 Good. 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 Yes. Good. Good. All right. So, as you read through these, what does scaling mean? And what does equiangular mean? In acute, it's only talking about one angle. Okay? And so the scaling is talking about all the angles being different, and this equiangular is talking about all of them being the same. So these are opposites of each other. Scaling means every angle is different. Equiangular, every angle is the same. Okay? All right, let's do B. Oh, no, let's not do B. Okay. All right, 234, number 3. So again, you can show me on your fingers what you think are the opposites. Or counterexamples, indirect proofs. No. No. No, no. Maybe I have the wrong answer. Let's see. Let's read these. Okay, each of the 2 items that Val bought cost more than $10. Then it says Val spent $34 for 2 items. Neither of the 2 items that Val bought cost more than $15. If 2 items, if neither one of the 2 items cost more than $15, what is 15 plus 15? 30. And this says Val spent $34 for the 2 items. There you go. That's right. So try again. There you go. There you go. Good. Good. Okay, so the correct answers were 2 and 3. Because $10, it says more than 10. But more than 10 could have made them where it's $34, right? More than 10 could have been 18 and 18 or 20 and 20. We don't really know. So that one wasn't quite enough information. All right. Look at number 4. Talk about it in your groups. See what you guys think. Yes. Sorry. Good. 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 No. Yes. Yes. Good. Good. Yes. Good. Good. Yes. Okay, so in a right triangle, ABC, A is 60. So that means right here you would have a 60 and a 90, correct? Which means that the other one would have to be a 30. Okay, good. All right. In a right triangle, so again you have a 90, right? And it says A has to equal C. Okay? And then the last one, in a right triangle, measure angle B has to be 90. If A is 60 though, could 60 and 60 equal each other?
No.
Would that work? Why not? Exactly. So that's why these are opposites. Because this one doesn't really give us enough information, right? Okay. All right, moving on. So if you're trying to prove that y does not equal 6, what would you end up doing to prove it wrong? Exactly. You would assume that y does equal 6. Okay? If we plug 6 in, what ends up happening? Can we see? Okay, solve it. So we're going to go 7, and then we have x plus 6 equals 70. How would we solve this? What would I do next? Very good. 7x plus 42 equals 70. Subtract 42. 7x equals 28. Divide by 7, and x equals 4. Well, at the beginning they said that x doesn't equal 4. So does this prove that to be a true statement? Yes. So, but the only thing you would really need to do is that. Except for I forgot to put assume temporarily. Okay. On your own. Page 236. Numbers 7 and 8. You just have to write the first statement assuming something. So what do you think? And really, in order to prove this, you would just need to write that at least one triangle is not a right triangle. Not that all 4 are not right triangles, but since they're saying all 4 are, you would just need to prove at least one is not a right triangle. Thank you. I meant angle. Assume temporarily quadrilateral ABCD in ABCD that at least one angle is not a right angle. Okay, last one. Write a statement that contradicts the following statement and draw a diagram to support your answer. Line A and B are parallel. So what would you say? Assume temporarily. What? Lines A and B. And I liked what someone said. It was intersect. Because really the opposite of parallel is that they intersect. And what would be an example to show that that's incorrect? I mean, to show that 2 lines could intersect. Yeah, you could do perpendicular, and you would just draw 2 lines. You'd label one A, one B, and here's the point that they intersect. Any questions?